Yeah, hello everyone. I see 4 attendees until now, so I will wait. For 5 minutes to start the session, and wait for other people to join.
And I'll just add to that, if you could send us your email address, the best email address to use in the chat to us directly in the Zoom chat, so we can send you the lab guide, the lab link, the live lab link, and also the PDF version of the slides we're going to be using today. We'll get that sent out to you so you have it when we're ready to get started on the labs. Thank you.
For the people that is just joining, we ask for the email to share some files. So if you can place your email address in the chat window, we can send some files. Okay, so we are 4 minutes ahead of the hour, so we will start right now. Hello everyone, I'm Christian Castillo, Cloud Security Architect for Americas, and this time we will present AWS Gateway Load Balancer workshop. This is a technical workshop where we will presenting how Checkpoint CloudGuard Network Security, which is our virtual gateways, will integrate with the AWS GWLB or Gateway Load Balancer solution to allow to inspect everything with an easiness of service insertion inside the fabric. With me is also Jonathan Mareski, the manager of product marketing for cloud security. I don't know if Jonathan wants to say hi or not.
Hi everyone. I'm not the brains in this workshop. I'm not even the beauty or the muscles. I'm just helping out. Nice to have you all on.
Thank you, Jonathan. And Jeff Engel, which is cloud technical marketing engineer, and he will be helping me by sending the email with the information, the email with the files. He put together the lab environment, and I don't know if you want to say something, Jeff.
Yep. Good morning, everybody, and good afternoon, I guess, for some of you probably. Happy to be here. Feel free to ask questions as we go. This is an interactive session as well. We don't want to bore you with a bunch of slides. It will be a lot of technical information, but feel free to interrupt us and or just drop it in Q&A or chat. Will work as well. And just one last call out. If you haven't sent us an email yet, or send us your email address in the chat, please do so. And I will send out the lab guide, the PDF version of the slides we're looking through today, as well as the live lab link. So you can launch a live lab in AWS. Thank you.
Yeah. Well, first of all, just to be clear, please do the questions that you want. Anything, please ask as much as possible, but do it in the Q&A window. Even if we can see the chat window and continue by answering some questions in the chat, managing the questions and the answers and whatever that we are not answering or what we already answer is pretty easy from the Q&A. So do all the questions in the Q&A, right? So thanks everyone. As I said, this is a workshop where we will be talking about and explaining how technically works the gateway load balancer solution from AWS with Checkpoint. And well, the first thing that I want to see is, I don't know, this is something that I need to ask to Jeff, but I don't know if he already has the poll. If there is no poll in the window, sorry, in the Zoom chat or something,
I can do it right
you can
now.
answer this. Oh, excuse me.
I'll do it right now. Yep, we can go to the next slide. Go ahead and fill out the poll so we know who's here, what's looking to learn. If you have any other interests, just so we have an idea.
Right, we will be focused on gateway load balancer solution this time. But if you have a question or something else, if you want to learn something else, please fill the poll, and we can settle down where we are right now and how to help you with some of the questions that you already have, right?
So we'll just give everybody a minute or two to fill it out.
We'll give you, I got 1 minute. I think it's enough to. Okay, well, hopefully everyone was able to answer the polling. And thank you for letting us know where you are and what you want to learn. Well, here's the agenda. The agenda. We'll explain the Checkpoint advantages. We'll go inside the nuts and bolts of the GWLB, how it works, what is the magic behind the GWLB. There is a good thing. You will have some architectural designs under the hood architectural designs, and you will be with a hands-on, right? So you can touch and deploy and play with a lab environment that we already provide for you. That lab environment is the one that was sent from Jeff. And
one thing real quick to add on the lab, it will be alive for about, I think it's about 24 hours. The lab environment is run by AWS, and so we're kind of at their under their rules. So it will not last forever, but it will be alive for, I think, at least 24 hours. So if you want to play after the fact, feel free. It's pretty much test whatever you want to test, even beyond what we do today in the lab.
Well, thank you. So first of all, what is Checkpoint right now? Checkpoint is it's a security company that has been here for decades. So we have like more 20 years providing first-rate security. We are also a strategic ISV security partner. We came together and we are together with AWS. So we are helping him to produce new products We are designing partners. We provide our security products for all the services from AWS. So AWS is a cloud leader for 10 consecutive years in the Gartner, and we are a global leader for different Gartner Enterprise Firewall MQs. And well, we have the security. We have our security platforms also compliant with SOC 2 type and SOC 2 type 2 and PCI. And basically, we are working together with AWS all the time. Checkpoint can enhance security for AWS, even if AWS has some services and they can provide some kind of protection. We can improve the protection with our CloudGuard solution. The CloudGuard, it's actually our portfolio for securing the clouds. We have security from network side, anti-posture, where we can see the configuration of the AWS platforms. We can protect the application at an ingress level. We can protect the web application level. We can also protect the workloads. So if you're using AWS Lambdas, we can protect the Lambda code and the Lambda executions, or even we can protect the Elastic Kubernetes services from workload, where we can see what the containers are doing and protect them. And we have at the end the intelligence, which is the threat prevention view for everything, where we can see how the APIs in AWS are used, how your users are interacting with the console, how your users are interacting with the APIs, and identify issues based on identities, right? Some identities being overused, identities being exposed, identities that should be used for one service and is used outside. So those are the things that we can deliver. We will talk this time for this workshop. We will go deep in the network layer, right? Because we'll go first for the network layer, where we are working with the gateway load balancer, and we can provide the threat prevention, security, and zero-day protection at that level, right? So we can protect anything that your workloads inside the network, inside the AWS fabric is doing, and provide all the solutions from our checkpoint gateways. So again, what is the first thing that we will do? It's the CloudGuard Network Security. It's our centralized managed security for the gateways. So we can provide a central plane to manage even on-prem and cloud environments. This is a unified version of all the management. This is a traditional SMS, the management, the smart one, I don't know. They have hundreds of names of this solution, but this is already the management console for even the cloud based gateways. With the different designs that we will show, there is capability to provide security for north-south traffic, which is traffic that is coming from the internet or going to the internet from the cloud, and east-west security. So this is traffic that came from a VPN to the cloud and goes to a VPC, or go from one VPC to another VPC. So we can provide also that kind of security. We'll explain the different architectural designs for that. And our solution is actually DevSecOps friendly. Why? We have different tools on the management station that allows the gateways to understand dynamically what you are deploying in the cloud. So you can provide tags or identifiers in your cloud assets or in your cloud environments, like a virtual machine, and immediately the management station will know what is the IP that belongs to that tag, and apply a rule based on that tag. So instead of going and figure out the different IP addresses that you have in the cloud, you can provide tags and provide rules based on tags. We will see also that in the different workshop that we will be handling. So what is the use cases for this? So you can provide zero trust networking by segregating everything. You can provide microsegmentation by using the most specific routes, and even providing subnet to subnet protection. and you can deploy different virtual firewalls. The different virtual firewalls, and why we are talking about the virtual firewalls is because our firewall has been based on software from the beginning of Checkpoint. So our firewalls are pretty high performance in the cloud, because we don't rely on any kind of specific chips or specific chipsets to accelerate our solutions. Our solution has been always accelerated by software. So you can expect, for example, 2 core machines from Checkpoint handling 1.5, 1.2 gigabits per second of throughput. And from there, you can go up, right? Like to 8 core machines that we can handle like 4.5 gigabits per second in one single machine. And that's why we talk about the virtual firewalls. It's a super performant and high performant virtual firewall, because we don't rely on any kind of specific chipset to do the acceleration. So I don't see any kind of questions. This is what we will be discussing. This is the Checkpoint benefits to provide threat prevention into the AWS Cloud Native Fabric. So let's go under the hood. We will go directly to explain the Gateway Load Balancer portion. Gateway Load Balancer is a service from AWS, right? That allows to provide routing points. That's the way that I will explain, and I will explain what is routing point. Routing points inside your different VPCs, and transfer traffic into security gateways, right? Transfer traffic into virtual machines that will be the security gateways. So how this works under the hood, right? The Gateway Load Balancer is essentially a load balancer, right? So I will do my annotations here. So I will do drawing. There you are. So Gateway Load Balancer is actually a load balancer. This is the load balancer here that is deployed. It's deployed in its own VPC. So you will have a VPC defined only for the appliances. This is the best practice. This is the best way to do it. And then you will have another portion. This is the routing point, right? You will have some Gateway Load Balancer endpoints, which is basically a service endpoint, right? An endpoint that will be deployed in the same VPC as the appliances, or in your consumer VPC where the virtual machines are deployed, and so on, depending on the design. And the targets for the Gateway Load Balancer are different appliances, right? These appliances are connected through GNIF. So basically, it uses the GNIF tunnel to do all the magic. Between the Gateway Load Balancer endpoint until the appliance, there will be a GNIF tunnel that is handling, for example, also the hashing mechanism to provide persistence or symmetry in the destination, in the target. So even if these appliances are just single gateways, so different and distributed single gateways, the Gateway Load Balancer will take care to maintain the traffic. So basically, the flow will be the packet, right? So a packet from internet, a packet from your EC2, a packet that came or logged or came into the fabric of AWS Fabric will be routed into the Gateway Load Balancer endpoint. The Gateway Load Balancer endpoint will send the traffic into the Gateway Load Balancer. This is the service, right? The Gateway Load Balancer will create a hash, and will create a destination for the target, right? So it will be sent into one of the appliances. The appliance will do the analysis, and the appliance will not route anything outside. Actually, this service works with appliances receiving traffic and just returning traffic, right? So when they receive the traffic, it applies all the security mechanism and all the inspection and all the things. And the encapsulation here creates a cookie. We return the traffic into the Gateway Load Balancer just because they passed the verification process. And the Gateway Load Balancer will return the traffic into the same endpoint that sent the traffic initially, right? So that's the way that it works, right? So as you can see, anything that you place here will not do routing, will not do NAT, will not do anything else than a security. And that's why we say that it's a service insertion, right? Because you essentially send traffic to this endpoint, you do all the magic behind with the GNIF tunnel, and then the endpoint, if the packet returns to it, will send the traffic into the destination depending on the route table, right? That belongs to the gateway load balancer subnet. So this is how it works. And again, everything from this side is encapsulated by GNIF, right? And that allows to the appliances to be multiple and distributed by this cookie matching and symmetry and maintenance, right? So let's clear this room. I don't know if you have any questions right now. No questions yet. So let's terminate the annotation. So what is the different architectures that we can use? This is a distributed gateway load balancer architecture where normally the use case it's for ingress or egress from a given VPC. So in this design, it follows a little bit the diagram or the flows that I showed in the past, right? So you have a consumer VPC where you will deploy your different instances or EC2 virtual machines, and the traffic will go into the gateway load balancer endpoint and be sent into a different VPC through the fabric of AWS, right? So what is this? What is here the different caveats, the different benefits, right? As you can see, we have a consumer VPC that has already its own internet gateway, so it doesn't need any kind of centralized or routing to send the traffic outside. Right, that's normally when the machines here has an elastic IP. Right, that's the use case. So let's assume that your machines already has an elastic IP, and the normal flow for this is this subnet, which is a public subnet, will send all the traffic to the internet gateway. So every time that the web server wants to go out, it will just go out. Every time that someone wants to reach the gateway or the EC2 instance, it will hit the IP that belongs to the internet gateway and send it into the EC2 instance, right? So that's the normal flow. There is different features that allows me to change this flow, where, for example, you will change the ingress routing, which is a routing table that applies to the internet gateway. So now you will say to the internet gateway, if you want to reach the private IP that belongs to this, which is associated to the elastic IP, right? So this is the PIP, the private IP. You need to reach the endpoint. So in this case, the traffic will hit the endpoint, do all the magic, return. This gateway load balancer endpoint is placed in its own subnet, so the destination, it's the private IP, and it will be sent here. Every time that he wants to reply, it will try to reply to internet. So it will send the traffic to the gateway load balancer endpoint. Again, the endpoint will say this reply belongs to a hash. So it will be sent to the gateway load balancer, and it will send to the same machine that do the traffic in the beginning and just return. And this says, the subnet says, if I want to go to internet, I just need to send the traffic to the internet gateway. So as you can see here, there is a simple way to introduce the checkpoint blade analytics or the checkpoint blade analysis without taking away the elastic IP that belongs to the virtual machine, without changing the way that the VPC is deployed, by just adding a gateway load balancer endpoint subnet and changing the route table for the internet gateway, for the different public subnets, and the route table for the gateway load balancer endpoint, right? So this is what we call a distributed GWLB architecture, because the routing point, it's inside the VPC, right? That's the main deal, right? So the routing point is inside the VPC of the EC2 instances, but the EC2 instances need to have a public IP in this case. The centralized GWLB architectural design, the centralized GWLB, it's to connect different VPCs. So if you have the use case, for example, to analyze the traffic between the spoke 1 and the spoke 2 and the spoke 3 and the spoke 4, so the different spokes that the customer is deployed, right? So you have here, here, and here. You can deploy a transit gateway that centralizes everything. The transit gateway will be attached, right? This is a VPC attachment, will be attached to the security VPC where the checkpoint gateway behind the gateway load balancer are deployed, where the gateway load balancer endpoint has deployed. So this is the main difference. The gateway load balancer endpoint is not anymore inside the VPC where the workloads are deployed. So in this case, you can simply send the traffic outside, and then the subnet will not know, or anything that is unknown from the subnet will be sent into the transit gateway. The transit gateway will be seeing everything that came to me, right, from all these spokes needs to be sent to the attachment. The attachment will send the traffic into the gateway load balancer, analyzes, send the traffic outside. Sorry, return the traffic because it's analyzed, send the traffic into the TGW again, and destinate it into the secondary VPC or the tertiary VPC or even the internet, right? So if the machine wants to go to internet, it will send the traffic to the gateway load balancer, go here, return, and then the gateway load balancer will send it into a NAC gateway. Again, the checkpoint gateway is not a routing in this place, so we cannot send the traffic to the internet gateway directly. We need to return the traffic because that's the way that the gateway load balancer works, and send the traffic into a NAC gateway and go outside, right? So this is a centralized where you can combine everything, and you can have a spoke-to-spoke capabilities, east-west capabilities, even communication to the internet, right, without a public IP, and everything will be centralized here, right? Even you will only deploy a couple of gateway load balancer endpoints and not a gateway load balancer endpoint per VPC, right? So this is a centralized version. Both has different use cases, and also both have different benefits or design taking place. In order to prevent asymmetric routing, right? We need to enable the appliance mode. If you want to know what is appliance mode means, it's when the traffic comes from different zones and can be sent into an appliance that has a stateful DPAC inspection. So in that case, the TGW will be the transit gateway will be known or notionable that they need to send the traffic to the same stuff all the time, right? Because again, the checkpoint gateways, even if they are not doing the routing, they are still stateful inspection firewalls. So as a stateful inspection firewalls, the traffic, the SIM packets, the replies for the SIM packets and everything should go to the same gateway all the time. And that's a mix between the appliance mode enabled on the TGW attachment and the gateway load balancer cookie management. So in this case, this TGW attachment enablement to appliance mode, it's done as at the CLI level, right? So now you need to enable it through a CLI, but this is something that you need to take care. So the appliance mode, how it prevents the traffic to flow in a different way. This is basically the explanation. I will redo my. There you are. Right. So basically, when an availability zone is talking, right, with a TGW attachment, it normally needs to be grabbed by the same availability zone. But what happens if you have the appliances in different zones, because the auto-scaling group will deploy the appliances in different zones? This mechanism will maintain the flow to the same zone. So it allows to send the traffic, right, to the gateway load balancer endpoint and grab appliances from this zone, but it doesn't matter if it would change, right? As you can see, it will change from zone to zone. So it will reply the packet, and the appliance mode attachment will allow to reply packets to a different AZ, right? So basically that's all. Again, there is a blog post from AWS where you can see the balancing or this prevention of asymmetric routing with the appliance mode. Let me... Right. The same with the cross-zone affinity. So basically, the cross-zone affinity is disabled when you enable the appliance mode, and this maximizes the flexibility or the ability of HA because it allows to send traffic, as I explained, to send traffic from one AC, so zone one, and change the traffic to another AC. The only thing that you need to take care is there is some charges from cross AC inspection. It's not so high, but sometimes the people wants to know what is the source charges that is behind everything. So the cross zone inspection or the cross zone disabling or load balancing, it's actually enabled on all of CloudFormation templates. All these things are deployed by CloudFormation templates, and basically it's enabled by default for us, right? Because we want to be capable to have the most high availability and the most capabilities to inspect the traffic in no matter from what AC it came, right? So I'm talking about ACs, not regions, right? So everything is still in the same region because the attachment points are regional, but again, maybe you can change from one AC to another AC because the appliance is in another one, or you are destinating the traffic to another one. So that needs to be enabled on the solution. There is a high number of architectural designs that we can provide to you. We discussed the simplest one, right, where the gateway load balancer are just it's just deploying one gateway load balancer solution. Behind you have different autoscaling group members or one autoscaling group member, but you can also provide, for example, I don't know, the ingress routing in a different VPC with centralized version of the solution, and provide different ingress points with the internet gateway. Or you can deploy as many gateway load balancer endpoint as you want and associated to the same gateway load balancer service. But meanwhile, you have the capability to manipulate the routing. And again, the routing for the gateway load balancer endpoints is defined by the subnet route table, and the different routing points, right? So the other subnets or the other endpoints needs to be placed where the route table of the machine allows you to send the traffic to it, right? So we show the central version and the distributed version, which is essentially the standard architectural designs, but we have been helping to different customers to provide like thousands and thousands of designs depending on what they need. One of the designs that I can explain to you, for example, which is a little bit strange, and actually it's like this design that you are seeing in the diagram. It's I had one customer. He wanted to inspect the egress and the ingress for an EKS, so a Kubernetes service, from an EKS deployed in AWS. So meanwhile, you can have the capability to understand the different services that will be involved, and you can maintain the symmetry. You can simply use this solution. I will explain a little bit what was my solution in that place, right? If you know EKS it's simply a control plane. So this is EKS, right? A control plane Kubernetes API service that relies, or in this case, it was not Fargate, right? So it was easy to. So that relies on worker nodes that is deployed on its own VPC. What I did for the customer, it's place the worker nodes in an internal or private subnet and deploy a public subnet in the same VPC, right? The public subnet was a subnet that has route table that points everything into the IGW. I place an IGW into the VPC, right? And that was the design. I instruct the EKS that every time that you deploy a service type load balancer that is public, that will be applied or that will be deployed in the front end subnet or public subnet. So what I did next is to create a subnet, right, per AC, where I deploy the gateway load balancer endpoints. And I create an ingress routing and a TGW attachment, right? So I create another subnet here with the TGW attachments. So every time that the EC2 instances wanted to go to internet, and since they don't have a public IP, the traffic will be sent to the TGW attachment, and this will be sent into the gateway load balancer endpoint, checkpoint, return, and NAT gateway, right? NAT gateway and internet. And so this was easy, right? So the instances here at this level has a 0000 pointing to the TGW. Then when they deploy an EKS or Kubernetes service, it deploys a load balancer here, right? So basically it deploys a load balancer. And I create an ingress routing on the internet gateway and send all the traffic to the subnets, to the public subnets, into the gateway load balancer endpoints. So now the traffic hits the gateway load balancer endpoint, go and do analysis, return, and hit the load balancer. So now the ingress traffic was capable to be seen by the load balancer, but first by the checkpoint gateway. And now in the checkpoint gateway, we can apply, for example, I don't know, country-based rules where this load balancer can only accept requests from Mexico. This load balancer can only accept requests from CDN service. This load balancer can only accept requests from, I don't know, from another cloud service, because we have the adaptable objects on the checkpoint gateway. And in that case, we improve the security group, right? Instead of only apply rules that says the port X, it's open to all internet, or the port X, it's open to these IPs, we can provide country-based, service-based, cloud service-based capabilities, and obviously the IPS, right? So now every traffic that hits the checkpoint gateway will be analyzed by the different flow, by the different blades, right?
Hey, quick question, Christian, in the Q&A that I don't know
Right,
offhand the answer. Do you know, do we support, or does it support cross-account TGW attachments?
Well, for the centralized version, yes, because at the end the traffic flow will came from the TGW, right? So if they can provide TGW cross region, or sorry, cross account attachment, it's okay, right? So if they want to provide a simple central version for everything, it's okay. Actually, I didn't answer this question because essentially is the next thing, right? You can do it by yourself. I see your question, Juan, and I see the question from a while. You can do it by yourself, but basically we have inside Checkpoint. Well, for the gateway load balancer architectures, I saw you. I tell to everyone it's pretty flexible. Meanwhile, you have the capability to do symmetrical routing, right? So we can continue. To answer the question from Juan in a deeper way, we already has a service with that idea, right? We have a service where the gateway load balancer endpoint is cross account. You will be capable to deploy a managed gateway load balancer endpoint that belongs that is attached to a service that is in another account that belongs to Checkpoint, and we can provide the capabilities to do all the checkpoint analysis without the heavy lifting of deploy virtual instances, right? So that's basically the same. That's basically the same idea behind what Juan asked it. It's if you can provide even you can provide a gateway load balancer endpoint from your other account and allow to that gateway load balancer endpoint to connect to your service, right? So from the account B, from the customer account B or subscription B to your owned subscription A, right? Where you will deploy the gateway load balancer, you can extend a gateway load balancer endpoint. Or if you already has all the networking with the TGW and you want to use the TGW as the central point or as the core of everything, you can allow or accept a TGW attachment that belongs to another subscription, right? I don't know if you will use this for to create a service for yourself, or maybe you're just simply asking because you have organizational distribution of everything, and I don't know, you have the networking subscription plus the shared services subscription plus the DevOps subscription and so on. So it's okay. You can use in that way, right? So if it's organizational, it's the same idea behind, right? So you can have gateway load balancer endpoints from your central subscription. If you will not use TGW, or you have the TGW attachment from different subscriptions, right? Meanwhile, everything is in the same region. I see no issues, right? So the network security has service from Checkpoint, which is a new preview solution. We can also invite you to use this if you are.
Yeah, we are actively looking for EA customers. So if you are interested, please let us know.
Yeah, so if you're interested, the basics of this new solution, it's you will have your spokes in your customer-owned VPCs. So you will deploy your VPC, you will deploy your spokes, you will deploy your subnets, and we will provide to you an access to a managed gateway load balancer endpoint. So we will place our own attached service routing point in your VPC, and you will send the traffic to us, and we will send the traffic returning to the gateway load balancer endpoint, and you can send the traffic outside if everything is good. Who handles the policy? The customer handles the policy. We provide you also a graphical user interface or a portal where you will be the owner of this tenant, but everything that relies on the virtual machine are managed by us, right? So we own the virtual machines, we own the supporting, we own
the version control, the upgrades, etc.
Right. So all the heavy lifting that is behind, right? So and you can simply use our solution to manipulate the traffic. It can work for egress, as I explained, or even it can work for ingress. As I explained in the beginning, you can simply provide a public IP to your load balancers or to your EC2 instances, do an ingress routing table modification, and send the traffic into the gateway load balancer endpoint and return, right? Juan, how is the troubleshooting to access these gateways? Basically, the troubleshooting, yeah, we will manage them, right? So you will put a support ticket and so on. But basically, this is backed up also by the gateway load balancer solution. And the gateway load balancer solution is capable to understand if one of the gateways is failing. The gateways is not just a gateway or neither an HA. It's an auto-scaling group, right? So if one of the gateways is failing, another gateway will appear by the template. If the gateway is failing and is not answering healthy to the gateway load balancer, the load balancer will stop sending traffic to that gateway. It will start sending traffic to another gateway to distribute or balance the traffic. So basically, there is not so much things that you can do for troubleshooting, even if you own the machines. Because if you own the machines and some of the machines doesn't work, I will tell to you, just kill them, right? You can just go and kill the machine, and the auto-scaling group will take care to deploy a new one with with the template-based solution and managed or backed up by the auto-scaling group, right? So that's the magic also behind the gateway load balancer that I didn't tell to you. It's everything is backed up by an auto-scaling group. So the machines are managed by the auto-scaling group asset solution. Right, and so FW monitor or TCP dump, right, through an SR ticket. Okay, so now that we barely explained, right, and you are not seeing anything by your hands and by your eyes and by your own feelings, we can start to do the hands-on training, and I can still continue to explain the flows, right? So to explain how the networking, how the routing, how everything where you place the gateway load balancer endpoint works. At this point, if you place your email in the list, Jeff Engel should send to you.
Yep, I know we've had a few additional people jump on since we mentioned it last. So yeah, if you haven't already sent me an email or an email address in the chat, please do so, and I will send you the lab guide, the PDF version of the slides we're looking at today, as well as the lab link, so that you guys can launch your labs and start the lab process.
Right. So I will just, in the meanwhile, please open the link. Please open the link and open the PDF. I will just give you some hints from the PDF. This is how to open the link. You will open it. You will be granted one-time password. You need to download the key, right? So this is everything is here, but I will just point the common questions. So you need to download the key, because in order to access the different machines that we will deploy to do the testing, to do the, I don't know, FW monitor even, or TCP dump, or whatever you want to do inside, you will need a key, because everything is key-based SSH access. You can use PuTTY, right? Because if you're using Windows, the key is downloaded on PEN file. So you need to modify it to PPK file in order to be useful for PuTTY, right? This is the console, so I will go to another one. Yeah, in order to obtain the IP address from the management station, so where you will configure or where you will connect to the smart console, you need to log in into the AWS account that we will share, that we will provide to you for a certain moment, and change to Oregon, right? Everything is deployed on Oregon. So if you don't put on Oregon, you will see nothing. And then look for the cloud formations, enable the nested view for the only one stack that should be there. Go to the outputs. So you need to look for the stack that is running. So this stack is, for example, mine. So it's the deploy to gateways and so on. And you can go to outputs, and output has all the IP addresses, right? So I have the URL, the ports, the passwords, and everything. When you see the 01 output, which is the smart console URL, you will see the URL that has an IP address, right? So you can see the IP address, and you can use that IP address to connect to the smart console through web UI, or smart console through the smart console to smart console. So the Windows application. So, well, this is the admin guide. I will give you a couple of minutes just to let us know if you were capable to log into the smart console, and we can continue.
Yep. So we can combine this with like a 5-minute bio break, etc. And if you can just work through and try to get access to the lab, let us know if you have any issues. Also, I wanted to mention, if you want to go back a slide or two, Christian, that had the YAML link in it, I wanted to point something out real quick. So if you have your own environment right there. So in this slide, you'll see at the top there, the YAML file. So that's the CFT for if you want to build basically that diagram down below, which is essentially almost a mimic, almost a mirror image of what we're doing in the lab today. That is the CFT to launch that in your own tenancy. So if you have a playground or a test instance or test subscription or whatever that you're allowed to work with, you can use that CFT to create a mimic of what we're doing today, and then go crazy, obviously. So just a heads up on that.
Yeah. Juan, this presentation in a PDF version will be shared with you also. I can copy and paste it in the chat window, but also you will have it. You will have it into the PDF version, right? So it's into the PDF version.
Yeah, one other thing that's going to be in the presentation slides, I think, is a link to like all of the diagrams, PDF and draw.io format. So we're giving a bunch of information, a bunch of links to files, and so you can have all the gory detail, whether you want it or not.
I just copy and paste the YAML file also.
Just had one new attendee jump on. Cyril, if you want to do the live lab, please send me your email, the best email address to use in the chat window to me, and I will send you the lab guide, the links, the slide presentation as well in PDF format, as well as a link to the lab.
Yeah, so as you can see here, if I return to the diagram, right, that was for showing. We have a security VPC and we have a services VPC, or where everything is deployed. Some of the services VPC has its own GWLB endpoints, and some of the subnets the VPC has an attachment into the TGW. So some of the subnets sends traffic into the TGW, some of the subnets sends traffic into the GWLB balancer endpoint to be connected into the same service. So as you can see here, the connection point, it's the service-based GWLB balancer endpoint into the GWLB balancer, right? So everything is service-based, right? So even if the one that is here, but the one that is here is routed by the TGW, and the one that is here is routed by the subnet. So as you can see also, there will be a different endpoints or hosts that will deploy, database, shared services 2, and the web tier, or the public-facing machine. The NLB will be inspect first and inspect second. So these will be the two different inspection points for the ingress routing, right? And as you can see, you will have listeners, and the target groups are directly the instances, right? So this is another thing that you will see, different than using the gateways as a routing, right? So if you use the gateway as a router, you can see that the listeners of the gateway, of the load balancers are public, and then the target groups are always the checkpoint gateways or whatever gateway, and then a NAT rule inside the checkpoint gateway to send the traffic into the different target groups or internal load balancers. This is a main difference also for within the gateway load balancer endpoint. Another thing that you will see three different gateways being deployed. This is single gateways, right? So it's just single gateways deployed in different ACs. The gateway load balancer will be the one that receives all the traffic and distributes the traffic between the gateways. So the gateways are not synchronized, right? How we can ensure that gateways will behave the same? The management server has something inside called Cloud Management Extension, and the Cloud Management Extension automatically grab every of the gateways that appears belonging to the autoscaling group or ASG and place the same policy to each of these gateways, right? So basically the management server will take care to have all the gateways in same conditions, in same configuration, and doing the same stuff, right? And the gateway load balancer will be distributing the traffic. That's why I was answering in a couple of questions that the gateway load balancer is the one that will take away one machine because it's not answering healthy, or continue sending traffic to that one. And the gateway load balancer is the one that is managing the cookie maintenance and the persistence inside the routing through the gateway load balancer on different machines. This is a security disclaimer. The first step of the lab guide tells you to use a super insecure rule base. At the end, in the cloud, even if the rule base is insecure, from the checkpoint side, we'll still be applying the blades, and you can still be using the security groups from AWS. So there is an option where you can still use the security groups natively from AWS, because those security groups are actually at the NIC level, right? So they are still applying. Even if you send the traffic into the checkpoint gateway, the security group still applies, the native security group from AWS, right? So that's something that we need to care. And well, you can check the EC2 load balancer targets become healthy because they are reporting back the services, and follow the test. So basically, I don't know. No one has answered if you were able to start your. Okay, perfect. So you were able to start policy. So we have one. So okay. If someone has issues by clicking the link, and I don't know, maybe your account is not created, you are not able to see the machines up and running. I don't know, you logging into the CloudFormation template and you see an error or something.
Oh yeah, did we show? We didn't mention the output part of the CFT, did we? So if you're not familiar with CloudFormation, oh yeah, there we go. It's in the directions. That's right. Sorry, I apologize. Thank you.
Yeah, I just given some hints.
Yep.
For the,
yeah, I forgot that I put that in there, so we're all good. Disregard.
Right, it's here. It's the step number 10 where you can obtain the IP addresses and everything. Garab told us that he was not able to find the link. I don't know if you sent an email to him or not.
Did you get the email, Garav? If not, I can just I'll give you the link in the privately in the chat here for you. 1 second.
Okay, Garav, you will receive the link in the chat. Okay. Another thing, there is an SK. So, well, tips and tricks. There is a post inside AWS that shows you how the gateway load balancer solution works. This is where they place the new Gaby load balancer aspects, right? So this is the how to integrate Linux instances to the Gaby load balancer. Again, this is based on Geneve, right? We do the Gaby load balancer Geneve encapsulation by the automation process on the CFD, so you don't need it. How to design your firewall deployments for internet ingress traffic flows. So if you want to do ingress traffic flow with the Gaby load balancer, so you have the different options. This is just to let you know different stuff, right? So you can study from here, from the post. At the end, our CloudFormation templates do mostly of the things by itself. So this is just to you for knowledge. Also, we have an SK. So I will open it.
Real quick, Christian, we have a question in there. I think I know the answer. So Peter, you're asking about the AWS console. So the AWS console is going to get you into AWS itself, but then you will also have to copy the Smart Console URL to get into the Smart Console application to create those policies. I'm not sure if I'm answering the right question, but I think that's what you're getting at.
Instead of open AWS console, I don't get the question actually.
Open console on my
page. So open console on your page. So you're talking, let me see. You're talking on the admin guide?
Yep, I'm looking as well.
Accept, email, survey. This AWS console, this link. Oh yeah, you need to log in into AWS console because you need to obtain you need to change into the origin region. You need to go to CloudFormation templates. You need to see all the stacks, view nested, go to the stack, go to the outputs of the stack and obtain the information of IP addresses and so on. So you need to log in to obtain the IP address. When you obtain the IP address, you can obtain the Smart Console IP address and log into the Smart Console. Right, so in the step number 13, you will log into the Smart Console. But first, you need to log into the AWS console and obtain all the outputs from machine. Right, so as you can see here, so click on AWS console, which is this one. So open the AWS console.
Oh, I think, yeah, yep.
Right, so I think you are saying this one.
I think it's that for, well, I think he was talking about if you go up to step 4. Go back to step 4.
Step 4?
Right there. Actually,
step 4 is to obtain
sorry, step 7. Step 7. Yeah, open AWS console just drops into another screen, which also says open console. So it's got a little confusing, but yeah.
So you click on AWS console and it sends you to this link.
Yeah.
And then you need
it's like a pop-up window. It's a little confusing.
Okay. In the step 13 kit, you need to go first to the steps or follow carefully the steps 8. Right, so you need to log in into AWS, change to Oregon, right? Click on services, look for CloudFormation, or you can search the service here. So you can type CloudFormation. Click on the CloudFormation service. It will give you to this stack page. Look for the stack in a nested view. So turn off the nested view, and you will see only one stack. This stack, if you click on it, it will show to you, the outputs, and then you can see the IP address. Right, so in the CP console, you need to admin, use admin, QWE123 scream. I don't know this the name of this character.
We can blame Mr. Kopko for that one.
Right, and the IP address.
Keith asked a question in the chat. I think Keith, is that what you're looking for? Is that username and password? Because that's on number 14, which is down below that page you're looking at for 13.
Yeah, well, I was asking the kid because he was what they need to enter into CP console. So it's the URL and the other one. It's not working. What are you receiving? It's yeah, you need the public IP, and that's why the step number 12. The step number 12, as the output of the CloudFormation, points to you to the HTTPS and IP address. Right, then you will need to use that IP address to put in the Smart Console.
And there's a question about which how to know which EC2 instance is which. Also, if you look at the CloudFormation output, yep, you saw it. It's in there.
Right. So in the
I think the easiest thing to do is to copy that text into an Excel spreadsheet and sort out the columns. All good. No problem, Juan.
Again, you can ask whatever. It's just yours. Yeah, the instances are up and running. The Smart Console only sees a single gateway. Maybe it's because the ASG it's applying the steps. The CME it's applying the steps, or is it still applying the steps? So Michael Demuro, you can SSH into the SMS and look an output for the CME. And maybe you can figure it out if the CME is still working, and maybe it's just finalizing some steps.
Yeah, it takes a little bit for them, the 3 gateways to get spun up and attached to management.
Right. That actually helps me. The question from Michael Demuro actually helps me to explain something. When the management station it's up and running, it has no checkpoint gateways inside the objects. And you don't need to take care to place the objects in the checkpoint gateway object in the SMS or the management station. There is a there's a cloud management extension, which is an API based called to AWS from the management, and that is taking care to put everything or initialize the gateways and put the gateways in the Smart Console. Right, so all the objects are automatically appearing. So if you don't see the 3 gateways yet, just wait a little bit, and you will start to see that appearing. And that's the cloud management extension working in the backend to do everything. Right, so that's the way that the auto-scaling groups, virtual machine scale sets, MIGs, or any auto-scalable solution that we have as supported, it's working right now. Right, so even the NSX deployment inside VMware uses the same solution, right, to deploy the new gateways and the new appliances. So well, Kit, the Smart Console will not have any IP address on the drop-down list. You need to type it. Because maybe your Smart Console implementation or your Smart Console installation is new. It should be a field to entry.
Okay, so Keith,
when you
yeah, I was
click
going
on
to say, well, if he's using the web Smart Console, obviously that's not necessary. But if you're trying to use a regular checkpoint FAT client, yeah, the public IP, the public IP is there in the output.
Right. So when you grab the public IP as the output, you can just simply go here to this one. If this says cloud, you need to click on server. and put the IP address or the HTTP or server name, place here the key WE whatever, and log in.
I'm gonna share my screen really quick. And real quick, Keith, are you trying to use the web smart console or the traditional fat smart, the regular rich client or the Windows application? Okay, perfect. All right, so I'm gonna share my screen real quick, Christian.
Yep.
I'm gonna organize my tabs here. Got too many windows open. Share. Screen 3. Share. Okay. So if you look at if you go to your, let's just start at the console itself. Can you see my screen? Okay. Christian, can you see my screen?
Yep.
Okay, good. All right, so I'm gonna go to CloudFormation. I'm gonna uncheck nested. I'm gonna look for the main stack, which deploys the whole thing. Go to my outputs, and then the very first guy is this one. And you want to grab this link, which will take you to, and I'm already logged in this other tab, but this will take you to the login page for Smart Console if you're not already logged in. So I'm already logged in, so it didn't prompt me for a login. But yeah, that very first value is the Smart Console URL that you need to go to get logged in. Yep, correct. And the username password is admin, and I'll log out and I'll redo it here for you.
Yeah, in the web portion, you don't need to specify IP address because the IP address is the link, right? So you are already in the IP address.
So just to repeat, just to show, am I not sharing anymore? Yeah, I'm still sharing. So you get the username and password. All you do is admin QWE123 exclamation point and enter, and you're good to go. It's possible Keith it wasn't ready yet. Very possible. I have seen that as well. So you might have been too fast. All right, good to hear you're in now.
Okay, so perfect. Let me so the let me go to the flows. Okay. So at the end you can well, this is the next. Yeah, you're welcome. The next tip and trick is a repetitive testing tool for AL2 CLI. So you can.
Yeah, if you wanted to, there's some tools you can use to simulate a bunch of traffic. Otherwise, pinging outbound is fine, or doing some curls or whatnot from the EC2 instances works as well.
Yeah, sorry, I was seeing a question. Well, at the end it deploys like all these things. So if you go to the outputs from the CloudFormation template, you will see different level of balancers, EC2 instances, and so on, right? So you will be deploying something like this, right? NLV first, GWL first, and so on. So now we will start to dig into the flows. So every use case is, for example, a centralized east-west traffic across a spoke. So we need to identify the gateway load balancer endpoint location and following the routing. So I will tell to you right now all the routing that needs to be done, all the routing that are happening behind in order to see the traffic that is hitting one VPC to another VPC in this case, for example. So first of all, we have your sub 01 spoke 01, which is a subnet in the spoke 1 database VPC. You have your EC2 instance inside the database VPC. and it has a route table in the subnet that says 0000 needs to go to the TGW, right? Because then you have a TGW attachment to that VPC, right? So the traffic, when the traffic is trying to go from here to here, right, to the ACV in shared services, sub 02, spoke 02, it needs to go first and ask to the subnet, where do I need to go if I want to reach 10.100.5.0/24? And since it's unknown, right? It's unknown for the VPC, so 10.100.0/23. It will not hit the local, which is the standard route table. It will hit the 000, which is the TGW. So it will be sending the traffic to the TGW. Then the TGW has a TGW attachment, which is this one, and some route tables that says when the traffic came, right, by the spoke attachment, by the propagation and association for route tables, when the spoke against, this is the TGW the second place. When the spoke again arrives, or the packet arrives from the spoke number 1, you need to send the traffic. If it's reaching the 000, you need to send the traffic to the gateway load balancer or security VPC attachment. This will place the packet into the TGW attachment subnet, right? So the packet now is here into the TGW attachment subnet. Now the TGW attachment subnet has a route table that says, if you want to go to 0000, you need to go to your per AC gateway load balancer endpoint. So as you can see here, the attachment points are 3. For example, we deploy three attachments on 3 different ACs for the security VPC. So every attachment subnet has a 000 as the next hop for its own gateway load balancer endpoint, as you can see here, right? So the gateway load balancer endpoint per AC, and so on. And all the NLV subnets, so all the network load balancer subnets also has its own IP. So, well, first the packet is here. Since the packet says 000 needs to go to the gateway load balancer endpoint, the gateway load balancer endpoint will reach the traffic. This will be sent into the gateway load balancer service, return, be analyzed, return, and be placed here on the endpoint subnet. The endpoint subnet, as you can see, it says all the VPCs that are attached needs to be returned to the TGW. If you are trying to go to 000, you need to go to the NAT, right? So when the traffic number 4 arrives here, the endpoint will ask to the subnet route table, where do I need to go? And it will be sent into the TGW again. Now the TGW has an association that says if the traffic comes from the security VPC, propagate anything that I has here. So it will be automatically says, you are trying to destinate to 10.100.5.0/24. So the transit gateway will send the traffic into this one and reach the destination. So as you can see, from here to here, goes to the TGW, logins into the solution, place the different route tables here, return, and then reach the destination. So now all the traffic, all the replay packets will return, will hit the same gateway load balancer endpoint, and so on, right? So do you remember appliance mode? So replay packets return to the same AC. So this is how it works, right? In the routing table, and this is how you will see the routing from east-west. Any kind of questions across the spokes? Oh, so now across the spokes, if you want to see the flow number 1, you can SSH into the EC2 host database or the shared VPCs. So you can simply go one side or the other side. It doesn't matter. And ping to the other IP, right? So you can just simply go and look for the IP address, for the internal IP address of your different machines and ping each other. And you will see, if you are using the any accept rule base with login enabled, you will see the host to host communication. So now you will be capable to see VPC to VPC communication. Okay, I will wait a little bit. I don't know if there is some question or not. I see Juan. That
Yeah,
says yes.
I'm helping one. He was having trouble getting into one of his EC2 instances, but I think it might be a policy issue.
Okay.
I
Yeah, don't
like to
worry.
call that layer 0, Juan, personally, but yeah, I get you.
Right. Don't worry. So now we explain a little bit the routing that is involved on east-west VPC to VPC, right? So I will be super clear. This was VPC to VPC, and everything was and all the VPCs are associated to a TGW attachment, right? So the TGW is the one that is centralized everything. So the next flow, it's a centralized egress, right? So now we need to identify and follow the routing for the egress. Right now, the next example, it's, for example, you have a VPC right now. The VPC has EC2 instances in a private subnet. So the VPC, so the EC2 instances doesn't has a public IP associated. So it doesn't has an elastic IP. It's completely a private facing subnet. And in this case, if it's a private facing subnet, all the private subnets, so all your private subnets of the different VPCs should be associated to a TGW because it's a centralized way, right? So we will centralize the egress. So now the EC2 instance wants to go to 8.8.8.8, and we will follow the same, right? So the EC2 instance will ask to the subnet. This is the first, all the instances inside AWS, all the instances inside the different cloud services ask first to the subnet because the subnet has a routing table and the subnet has the default gateway. So it asks to the subnet, and the subnet says, where do you want to go? 8.8.8.8. 8.8.8.8 doesn't belong to your VPC, 10.100.4.0/22, which is my first route. So my second route is 000 to TGW. Okay, this hits this route, right? So go to the TGW. The TGW again has an association, so the ingress route table. So the association that says if you came from any of the different VPCs and you are trying to reach 0000, so whatever, you need to go to the security VPC attachment. So the next step is the TGW sending the traffic into the TGW attachment subnet. Now that the TGW attachment subnet reached the traffic, the TGW attachment subnet asks the same thing. And again, the TGW attachment subnet has a 0000 route table to the gateway load balancer per AC. So it will send the traffic to the gateway load balancer. It will communicate the traffic into the service, inspect the traffic, and return the traffic. So now the gateway load balancer endpoint needs to decide, where do I need to go? So it asks to the route table on the subnet again. I need to go to 888, what I do. And 000 needs to go to the NAT gateway. So it will send the traffic into the NAT gateway, go outside, reply, return to the NAT gateway, return to the endpoint. So now the reply packet will follow the same flow. And now the reply packet is sending or destinated traffic into the, destinated traffic into the TGW and return the traffic into 1.100.5.0/24. So this is the flow, right? So all the reverse flow is the reply packet. So this is the flow. Route table here needs to have 000 to the TGW. TGW needs to have a route table attachment that send the traffic into the security VPC. The TGW attachment subnet needs to have the 000 going to the specific gateway load balancer endpoint, and the gateway load balancer endpoint needs to have the reply packets to the spoke going to the TGW and 000 going to the NAT gateway. In this case, all your VPCs, if you connect different VPCs to the same TGW, every VPC can use this auto-scaling group of checkpoint gateways and these 3 NAT gateways or per AC NAT gateways for everything. So you don't need to deploy internet gateway on each VPC. You can simply deploy the central security VPC and use all the internet egress from here. Thank you, Juan. Yeah, if you are using Nix-based machine, which is Mac OS or Linux machine, the PEM file has permissions to see So permissions to be seen from everyone. So you need to change the permission to 400. Otherwise, the PEM file cannot be used, right? That doesn't happen on PPK. So if you convert everything into PPK with PuTTyGen, PuTTY doesn't care if everyone can see the key. Now, any questions on egress traffic, right? So in this use case, the centralized egress, again, you can simplify the egress by, or you can do or create a design where the egress it's in only one place. So all your VPCs doesn't need a public IPs associated. All your EC2 instances can remain private. All your VPC cannot utilize internet gateway associated. So basically you create all your VPCs in a private basis, right? And you can still give them internet access with inspection, right? So now the centralized egress testing is you need to SSH into one of your machines and the database of the shared services, I don't care. And ping, well, ping AA8, so you will see the RCMP or even CRL. CRL is a processor, it's a program, or it's a binary that allows you to do a check URL or grab a URL, or basically an HTTP request into different services. So if you do a CRL www.google.com, you will receive a 301 maybe because there is a redirect. But you will see the traffic hitting on the checkpoint gateway. So now you can go into your smart console, into your smart dashboard, and see the traffic directly on the checkpoint gateway, and you will see all the flows, right? So now you can apply network-based or firewall-based restrictions, or you can apply blades-based restrictions, right? Like application restrictions or so on. I don't know, any doubt here? We are still green. I'm a perfect teacher. I will go to the university to teach some people because it seems like I'm explaining everything pretty clear.
Yeah. If any questions, feel free to put them in the Q&A.
Yeah,
I'm guessing people are probably also working through the labs a little bit too at the same time. So it's
yeah,
all
yeah. I will assume yes. So just listen to me. Continue with the continue with the lab because everything that I say to you, it's how it works. But if you found something in the lab, if you well, Juan seems to be like an expert in
yeah, actually this came up in a previous session actually last night or yesterday. So export timeout will work kind of, but not really, because there's actually a hard TCP timeout on Gateway Load Balancer of 350 seconds. That is a timeout that we cannot change. So if there's no activity on that SSH session, it will, even with export timeout 0, it will still kick you out. So to avoid the timeouts, and I appreciate you bringing this up because I forgot. Go ahead and start out just a continuous ping. That's the best way to keep your sessions alive. Yeah, because remember, you are not reaching the machine directly because the machine doesn't have a public IP, or at least some of the machine doesn't have it. So you are reaching the load balancer, and the load balancer can kick you out. Now the third flow. This is based on a new feature also. The new feature is enhanced routing or most specific routing, and this is how to inspect traffic that wants to go from one subnet to another subnet. This is only so be careful with this one because it needs a lot of routing, right? But there is some cases where a customer, or some use cases where some VPCs are, I don't know, maybe zero trust VPC or PCI based VPC, and the people needs to analyze the traffic within the VPC, right?
Remember the first east-west use case that I showed to you? I was pretty clear that by saying this was a VPC to VPC flow based on the TGW communication, because it doesn't work for subnet to subnet, right? So the true flow is subnet to subnet. What is subnet to subnet? Let's say that we have only one VPC, right now, and this is a zero trust VPC, PCI VPC, any kind of VPC, right? And you distribute the tiers on subnets, not on VPCs, right? So if you distribute the tiers on subnets, you can specify, or you can create now a most specific route table. The most specific route table inside AWS needs a routing point inside the VPC. You cannot send the traffic, for example, for a most specific route into anything that doesn't belong to the VPC. So essentially what you need to do is, this is the same flow, right? So let's assume that the subnet 01 spoke 02 machine, this is EC2, which is the 10.100.40/24 wants to talk with the 10.100.5/24. But you still has a 10.104/22 as the VPC. So by default, you will see here in the route table, one thing that says is spoke VPC local and a spoke VPC2 local. When it says spoke VPC local, that means that everything will be handled by the fabric. So with the MSR or the enhanced routing, now you can specify the sub 02 spoke 02 needs to go to the gateway load balancer 2. But if I want to talk with all the VPC, I need to go to my gateway load balancer per AC. So you will deploy a gateway load balancer per AC and specify all the spoke needs to go to the gateway load balancer, but the other subnets needs to go to its own gateway load balancer, right? Because this gateway load balancer belongs, as you can see here, to the other spoke. So now the traffic will need to go to the 10.100.5. It will be sent into the second route. It will be sent into the gateway load balancer sub 02. The service will associate the traffic into the gateway load balancer and return. And this gateway load balancer subnet will send the traffic by the local, right? So the gateway load balancer, this needs to be in a different, the gateway load balancer endpoint needs to be in a different subnet, because the gateway load balancer needs to know how to reach everything by the local. So it will return the traffic to the local fabric and send the traffic into the other EC2. So as you can see here, it's doable. It's doable in a centralized, it's doable in the distributed version, but you need to have gateway load balancer per AC of the subnets and subnets per gateway load balancer endpoint, right? So this is, again, it's doable. You need to take care a lot of the routing. It's not super crazy. Right? But there is some use cases that need it. Right? I tell you, it's a zero trust subnet, PCI subnets, tier based by subnets, because there is some people that doesn't distribute the tiers by VPC, they distribute the tiers by subnets. So even in that case, if they need it. But in this case, you can specify this and you can inspect the traffic, right? So how we will test them? You need to create the route tables, as you can see. So right, so the admin guy will follow you to route tables, because at the beginning the pings will not work. You need to connect to your shared services host, which is behind the NLVs, and you need to specify the route tables to go to the VPC endpoints, specifically per VPC and per subnet. And then you can simply do an ICMP test, and you will see the subnet to subnet, right? So the traffic inside the same VPC going through the checkpoint gateways. Again, this is more, the checkpoint gateways is still there. The checkpoint gateways is just associated to a service. This is more like how the routing tables inside AWS works, right? So as I told you, by default, every routing table that belongs to a VPC has this spoke VPC, which is the CIDR block, needs to go to local. If you want to replace this, you need to have a routing point inside. So a virtual machine that has routing, these VPC endpoints and so on. But if you associate a routing, if you associate a TGW, there is no way to put a TGW, right? Most specific than the spoke VPC, because that's not allowed by AWS, right? That's why we need to deploy gateway load balancer endpoints here instead of using the TGW to centralize everything and maybe simplify a little bit the deployment, right? It's because the most specific route works in that way, right? So there is no doubt for that. No? Perfect. So now the flow number 4. The flow number 4 is distributed. So the distributed, again, remember, distributed is you need to place gateway load balancer endpoints in your VPC and connect it to the service for the gateway load balancer endpoint. Sorry, gateway load balancer endpoint in the VPCs and connect to the gateway load balancer. So this is the next one. So in this case, what happened if you have VPCs, right? Or the use case is you have a VPC. The VPC has its own internet gateway. That means that you can deploy public-facing load balancers or elastic IPs associated to the EC2 instances. That's what you can do when you associate a VPC. When you associate an internet gateway into a VPC, right? So in that case, this EC2 instance has a public IP, right? How it works? The internet gateway, when you associate a public IP into the instance doesn't have the public IP. The instance is still deployed in a private CIDR block, right? So it still has only a private IP, but the internet gateway has a 1.1 NAT that says, you associate an elastic IP to the EC2 of 201, 201, 201, 201, right? So that's the IP address. And it's associated to this EC2. So I need to create from the internet gateway, and that's by the automation, a 1-to-1 NAT that sends the traffic, so that the traffic that hits 201, 201, 201 hits the internet gateway, and it will be sent into 10.108.0/24. That's the way that it works. And that's why we can use the gateway load balancer endpoint here and use another solution from AWS called ingress routing. Ingress routing allows me to put a route table associated to the internet gateway. So now we can say to the internet gateway how to reach the internal IP addresses. The route table by default will look in this way: spoke VPC 3 go to local, and we can specify 10.100.8/24 needs to go to their own specific gateway load balancer endpoint. In this case, as any distributed way, you need to create subnets per gateway load balancer and gateway load balancer endpoints per AC, right? So in this case, we deploy the gateway load balancer in its own subnet, and the traffic now needs to go here. Then the gateway load balancer endpoint has the VPC local, so it can reach anything on this address space locally. And if it needs to reach internet, it will go to the IGW. And the trick is here. If the EC2 instance needs to go to internet, instead of going to the IGW directly, it will go to its own gateway load balancer. So now if the traffic comes from the internet and hits 201, 201, 201, it will hit the internet gateway, and the internet gateway will try to reach 10.100.8.0/24. The route table will send the traffic into the GWLB endpoint, and the GWLB endpoint will send the traffic into the service and return. And then the destination was 10.100.8.0, so it will be sent into the EC2 instance. The same will be happen if the EC2 instance wants to go to internet. It will try to go outside. It will reach the internet. It will reach the gateway load balancer endpoint. It will do the analysis, will return, will send the traffic into the IGW, and since the IGW will see the IP address on 10.100.8.0 that belongs to the EC2 instance, it will do the 1.1 NAT and apply the NAT for outbound. So this works for ingress and for egress, right? So you can now have some DMZ VPCs where you will place your internet gateway and the public-facing load balancers or public-facing machines, and you can inspect the ingress traffic and the egress traffic, even if the machine has a public IP, and you don't need to take care of any kind of NAT at this level. The only NAT that applies is this one, and this is automatic, right? Because this one is managed by AWS. But you need to take care of it, of NAT, port address translation, or whatever here, right? So this also simplifies the deployment. If you are using gateway load balance, if you're using public IPs directly associated to the EC2 instances or NLBs, network load balancers, you will see on the IP addresses the public IPs, right? So now you can see the traffic going outside and the IP address that belongs, and the traffic going inside and where they came. So you can see the public IP hitting the elastic IP associated to the EC2 instance, or you can see now the EC2 instance trying to go outside with its own public IP. Again, you will see the private IP all the time because remember, the public IPs or the elastic IPs doesn't belong to the machine. It belongs to the internet gateway, right? So what you are seeing, it's the traffic netted by the internet gateway or the traffic originated by the private IP of the EC2 instance before the NAT that will be applied by the internet gateway for egress, right? So that's clear. The testing you will do, the testing that you will be doing is SSH into the WebTR EC2 private IP with the key pair. That's an EC2 instance with a public IP associated, so you can ping and CRL to the internet, and you can search for the IP address of the machine, and you will see your SSH session ingressing, and you will see the CRL port 80 egressing or the ICMP test. I don't know if you have any questions on this one.
Let's take a quick 5-minute break, Christian. Let people get a little more progress in the lab and then take a bio break.
Yeah, I need to go for a coffee. So
yep, me too.
Let me go for a coffee. We will put a mute. When I return, I will see all the questions and the question and answers. So if you have anything, please, again, let us know.
Yep, and for Peter, for your question, hopefully I answered your question. If you are looking for the install policy button, yeah, you're correct. It is not in the top left like it is on the smart account or on the fat client, but it is down below in the next section, right below publish, kind of in the white, I guess. There's a blue down arrow button for install policy. Hopefully you found it.
Juan, I will need to see your login. It should log every session. We have something called suppress logs, but that's only when the logs belongs to the same session. So I don't think that suppress logs is the one that you are seeing. You should see all the logs unless it's only one session, and in that case, well, you will hit the suppress logs because we don't want to worry on everyone. If you already know for hosts, you should be capable to look for all the logs. Well, if you are pinging actively, you will not see the each ICMP test, right? But you should see one at least for each of it. And Peter, I don't know what you are referring to. So I think. Well, the inbound, I think you will see you're seeing only one because that's the first step. I don't know if the load balancer are already behind the checkpoint gateway or not. But well, you should see the one with the public IP, which is this one, the web tier. That's for sure. The other ones behind the LVs, I don't know if they are already deploying that way or not. We'll see it. So okay, so let's continue. I don't know, Juan. I don't know if they're behind the gateways or not. You can put them, but I don't know. If you remember, the subnet to subnet was not ready until you hit the subnet to subnet. You prepare the route tables. So I don't know if the other ones are behind or not. I will assume yes, but I don't know. Okay, so now a few words to ingress. AWS create a blog post on how to design your firewall deployment for internet ingress. Let's wait. Yeah, so as you can see here, the traffic was distributed. They will say that you can send the traffic from your CloudFront to your AWS WAF and hit the application load balancer. So you can hit the application load balancer and ingress in. You can also use the AWS firewall networking and set the elastic load balancer. So this is the options. One of the options is this one. So you can send the traffic from the ingress route into the gateway load balancer to be inspected by a third-party firewall, which is us, and return that traffic into your elastic load balancer. So this is what we will be using. Right, let's do this side and continue. So now the flow number 5 is how to centralize the ingress flow, and the inspection will happen after the NLB, right? How is the inspection happening after the NLB? If you deploy your security VPC in this way, right? But also you do the internet gateway ingress routing into the centralized into the centralized security VPC, and you front everything to the gateway load balancer. So to the network load balancer, it will send the traffic from the network load balancer into the gateway load balancer endpoint. Then the gateway load balancer endpoint will send the traffic to be analyzed and returned, and it sends the traffic into the AC. So into the EC2, right? So all the reply packets will return the same way. So in this case, as you can see here, what we'll be seeing is the traffic, right, that belongs to the target configuration, right? We will not see the traffic that belongs to the internet gateway. So we don't see the public IPs hitting the network load balancer or the application load balancer. We will see only the NATed, right? So all the sources will be the same. Right? In this case, if you see the traffic in this way, all the sources will be the same. Main benefit of this solution, it's since the checkpoint is not inspecting between the internet and load balancer, you can apply the SSL management certificates or the SSL decryption from the application load balancer and send the traffic decrypted and already SSL terminated into the gateway load balancer endpoint, right? So in that case, the checkpoint gateway will see the traffic clear, right? So that's the main benefit, but you will not see the public IPs on the checkpoint gateway. You will only see the IP address that belongs to the application load balancer, right? No support application method. You need to use Sudhir. You need to use the key. You need to convert the key, the PEM file into a PPK, and you need to use the key in order to log into the machines, because everything in AWS it's SSH key. So in this case, this is the flow, right? So you can deploy your load balancers, your application load balancers, your network load balancers in a different VPC or the centralized VPC. That VPC will have the internet gateway, and the targets will be behind a transit gateway, right? So your load balancer will never be in the same VPC as your targets. In that case, you can do this, right? So you can inspect the traffic when it hits the load balancer, and the NATed traffic will be inspected. So you can use the SSL certificates and so on, right? Same idea. Load balancer is deployed in a subnet. That subnet for the load balancer, should has the gateway load balancer endpoint as a next hop for the spokes. So every time that the load balancer needs to reach the target, will ask to its own subnet, and the subnet will be asking for the gateway load balancer, for a specific gateway load balancer to be analyzed, right? So it's the same flow, but just for ingress. Again, if you do the SSH to the NLB inspection point and use the default key with the 80/2022, you can search for the 10.0.13/24, right? And the internal host database, which is behind the 10.100.0. So as you can see here, you will see the load balancer reaching the IP address reaching the port 22, right? Again, this is after the load balancer. So everything that you will see is NATed, right? So that's the only caveat, right? You have the benefits to use the free SSL certificates, because the free SSL certificates can be associated to the AWS services. You can use the SSL decryption, because the SSL decryption can be applied into the SSL decryption can be applied in the service, in the ALB service directly, but you will not be able to see the public IP, right? So that's the main thing. Anything? Any questions or something? No? Okay. We'll continue. So now the next use case is the same, centralized flow, right? But now the inspection is happening before the NLB. So if you have an NLB, for example, and you will say, no, I don't want to SSL decrypt directly. I don't need to do the SSL certificates and so on, or you are not trying to pass the traffic decrypted. You can use the v4 NLB. So in this case, essentially the database is on the same, so it's attached to the TGW. The gateway load balancer, sorry, the network load balancer is again a centralized version, so you can deploy. This is a good practice. Deploy the NLBs or anything that is publicly available in its own VPC, and then you can do the routing in this way. So the internet gateway, now you will apply the routing in the internet gateway. Right? The internet gateway needs to send the traffic to the gateway load balancer when it tries to reach the subnets where you deploy the NLB. So in this case, the internet is trying to reach the IP address for the public IP address of the NLB. It will first reach the gateway load balancer endpoint, send the traffic to be analyzed, return, continue the traffic into the NLB, and the NLB will send the traffic to the destination over the transit gateway. But again, in this case, you see the traffic that came from internet. So now you are seeing a specific public IPs that is hitting, and also this will need a new gateway load balancer endpoint per ingress, per subnet where you want to deploy the SSL. Sorry, the network load balancer per AC, right? So now if you go to the NLB inspector first, .8033, you will see the public IP address. So if you now look for your public IP address, you will see your public IP address as the source and not seeing the private IP address of the network load balancer as the destination, as the source, right? So this is the two use cases. Again, this is pretty useful because you can now architect zero trust, fully isolated, only public facing stuff in one VPC, be inspected by the gateway load balancer endpoints, be inspected by this centralized security VPC without the struggling of NATing and not associating IPs and associating IPs only to the checkpoint gateways and associating IPs only to the load balancer that belongs to the checkpoint gateway. So now you don't need to take care of all those things. You can simply take care of the gateway load balancer endpoints and the routing table inside the different subnets. And you can keep your instances, right? So all your VPCs where the workloads are deployed, purely private, right? So that's the main benefits of this solution, the gateway load balancer endpoint. And again, all the stickiness, all the flows, all the distribution, everything now it's happening at the gateway load balancer endpoint solution. So the gateway load balancer solution. And you are relying on AWS service for everything. So now this was the 6 different flows that you will see on the workshop training admin guide. And there is
yeah, to be fair, the admin guide I don't think covers every single flow. I think it does cover flows 1 and 2 and possibly 3.
Okay.
Some of these are not completely covered. However, you can, using the guidance in this in the slide deck, it does kind of clue you in on what changes need to be made, if any, to make it work. All the components are there, but the step-by-step instructions are not necessarily all there in the lab guide.
Okay, so Juan, that answers your question, and not all the flows. You cannot see all the flows because essentially not all the route tables are applied properly on the lab guide. You will have your lab environment 24 hours up and running, so you can play with it, change the routes, point to the different services that is there, to the GWLB load balancer VPC endpoints, and you can simply see now all the traffic. If you have some doubts, you saw my email at the beginning, so we can keep in touch if you need it. How do I use the private key in PuTTY with the DNS? Well,
I can share my screen really quick if you want.
Yeah, the login prompt is okay because you will be asked for the user. Juan, transit gateway to gateway load balancer is not like transition because you still use the transit gateway, right? Remember, the transit gateway is actually the centralized point for routing. What you will do is it's changing the routing to now be using the gateway load balancer endpoints, the VPC endpoints, to associate these to different services, right? So it's not like you're stop using the transit gateway, right? And that's actually a pretty simple design. If this is a pre-sales, I'm a cloud security architect for all America. So if this is a pre-sales task, POC, or something that you will do as a pre-sales or architectural design or something, you can contact me also because I can help you with the POCs and I can help you with everything.
And so, Peter, hopefully you can see what I'm doing here, or saw what I did. But once you go to the SSH and add the key, and then log in, as long as the key is there, you get the login prompt, you use EC2-user, and you get authenticated. I'll go do that one more time from scratch, just so you saw at least the first part, not the whole thing, but the first part anyway. So I'm gonna grab the DNS name, gonna paste it into here. I'm gonna remove the custom port off the end of the name, 8022. You have to go to SSH, auth, browse to your PPK file, and then you can just hit open. This maintains that session that we had started up here. So you hit open, it'll launch the PuTTY window and get you to your login prompt, and you do EC2-user. And as Juan said, you can also put that in your username and data if you want.
Connection, data.
Yep.
Then connection, data. Next one. No, connection, that one. How to log in username.
Yep.
You download a TXT. No, PuTTY cannot convert a TXT into PPK. Just your file should be a PEM file, and you can convert a PEM file into a TXT. But basically, you need to open PuTTYgen. So open PuTTygen, Jeff, please.
Yeah, I can walk through that too. So real quick, I'll do that whole process as well, Peter. 1 second. So I have PuTTygen installed. I'm gonna run PuTTygen. Through a window. And so if we go back a step real quick, so if you clicked on the SSH key, this hit for what if you're using PuTTY, you can just do download key, which is going to save that file as a PEM file. You can save that just as is, as a .pem file to wherever you need to. Go back to PuTTygen. We're going to load that PEM file. In my case, you have to change the format to not everything. So that's where I put my PEM file, hit open, successfully imports it, and then you're going to save the private key. So you save the private key, and then I'm going to say, yes, I don't want a password for now. And then you just give it a name, and then you have your key file with the PPK extension, hit save. And that's then what you would reference in your PuTTY session to log in to the instance. Hopefully I went slow enough for you. So one more time, download your PEM file to a location you can find. Load that PEM file into PuTTygen.
Peter, it's normally when you install PuTTY, it has PuTTygen normally. It has PuTTygen as the utilities. So maybe you can click on the home taskbar.
Yeah, well, if you install, like if you don't, sometimes if you install just the exe, you won't get it. But if you install the full package, if you right click on PuTTY in the taskbar, you might see run PuTTygen right from here in the right click menu.
Right. Well, hopefully this helps you, Peter, to continue. Otherwise, just let us know again. Okay, so now that I said all the flows, and again, not all the flows are in the admin guide, but if you follow a little bit this, if you see the diagrams, let me return to one of the diagrams. If you see the diagrams, you can figure out that maybe to test decentralized, you need to deploy an ingress routing table here on the internet gateway. You need to apply ingress GWLB subnets. You need to apply spoke route table to the NLB subnets and so on, right? So you can figure out a little bit by following this. Okay, so now I will continue a little bit with some gateway load balancer considerations. The first one is the flow stickiness. As I told you, there is a gateway load balancer flow stickiness or hashing mechanism where the gateway load balancer, when it receives the traffic, it create a hash for the session, and all the traffic will be sent into the same gateway. So for TCP, it uses 5 tuple. For UDP, it uses 4 tuple. Now, I've listened sometimes when I start to do the architectural designs for the customer, I always ask for the customer what traffic you will use, right? So in some point, maybe he will point me into some spaces where they say, I use like multi-layer, I use like multi-session protocols. I use like protocols that maybe the tuple 5 stickiness or tuple 4 stickiness will not work, right? In that cases, what I encourage normally, it's still using the same ideas, right? You can still use the same idea of ingress routing. You can still use the same ideas of transit gateway, but maybe for those flows in specific, not for all the flows, for those flows in specific, you can use an HA deployment where there is 2 appliances that will grab the traffic directly. In that cases, the routing table can point to the virtual IP or floating IP of the HA deployments. And you can still use for all the other protocols, for all the other flows, the different, the gateway load balancer endpoint. In my opinion, the gateway load balancer endpoint is the way to go. I know that there is some places or some stuff that you need to take care TCP, WebSockets, and so on. So that's something that you need to know. The other thing, if one of the gateway fails, right? If one of the members fails, the way that the hashes works is lifetime. So until the TCP breaks or the UDP breaks, it will try to send to the same gateway, right? The new sessions are not sending into the same gateway because it's now reported unhealthy, but the old sessions are trying to be in the same. So again, this is something relevant for WebSockets or some of the always on based sessions. So in that cases, you can also try to define that maybe that traffic can go to the HA, because in this case, if an appliance crash, the TCP needs to be reestablished, right? We discussed this at the beginning, the flow idle timeouts. This is by default, as Jeff says, there is no way to modify it, but by default, the timeout for TCP is 350, the timeout for the UDP is 120. Now, remember that I encouraged several times that the gateway is not routing anything, right? So with that in mind, obviously the VPN is not supported, right? Because the VPN means something outside from the fabric being routing inside of the fabric, and that is not allowed for the gateway load balancer architectural designs. But if we back up a little bit and we go into one of the designs, just like this one, for example, there is a simple way to overcome this. You cannot do an internet VPN based directly on the machine, because it will need to route something inside the fabric, and that's not allowed, right? That's what I was explaining. But what happens if my customer needs a central core for everything? And the TGW, it's also a BRF and multi-routing solution. So you can create a VPN attachment. This is an IPsec standard VPN terminating directly on AWS, right? And the transit gateway will put that traffic inside the fabric. So now with a TGW route table association, you can send the traffic to the endpoint, analyze it, and send the traffic to the destination. So in that case, you can terminate a VPN directly on a TGW VPN attachment, right? So that allows you to create a on-prem or site-to-site VPNs and send that traffic into the checkpoint gateway, because you can still route that traffic into the gateway load balancer endpoint, because TGW already put that traffic inside the fabric, right? So that's a consideration. Again, that's a consideration that you need to take care, but it's something that with architectural designs we can overcome. Actually, that's my main job inside Checkpoint, is that it's listen customer needs, listen customer use cases, listen how the customer is using the cloud, and I can figure out the different use cases. And again, for example, in that case, this security VPC can also have another subnet with an HA pair, and only some source and destination traffic can go to that HA, and all the other stuff can go to the ASG, to the gateway load balancer and gateway load balancer endpoints, and so on, depending on the routing, right? And at the end, the cost. As I told you, the gateway load balancer, it's a service. So the gateway load balancer deployment, it has a per hour basis cost, and the gateway load balancer endpoints has a per hour basis cost, and also a data charge. It's not so high. Even if you came from transit VPC deployment, it's as far as I remember, last time that I tried to do the quoting, it's a little bit less expensive, or it's a little bit cheaper than the transit VPC deployments, which is normally the other way that the people was deploying some stuff. So this is all. Now it's a big Q&A. So now we'll be waiting for 5 minutes to receive all the questions. I think you already passed all the admin guide flows. Please don't keep any doubt. We are here to answer anything. Also, if you saw my email at the beginning, I will put this. I will put the first page again. Right. So I was asking to you if there is some questions or not.
Yeah, I'm willing to hang out for a few more minutes. I know people are still working through the lab. I did get confirmation that the labs will be available until at least tomorrow morning.
Okay, perfect.
So, good to go there. And feel free to send us emails, after the fact, no problem. Reach out. Happy to help.
Yeah, well, perfect. So as a summary, I will keep here until the next 10 minutes. So as a summary, just get hands-on, get used to the GWLB balancer solutions. Now you know the routing mechanism that needs to be involved. Understand all the flow. Meanwhile, you can understand the flow. Meanwhile, you can return the flows to the same LB GWLB balancer endpoint. You will be capable to do any kind of crazy architectural design. And well, sign up for the NSAS EA. We're continuously looking for people that want to join the NSAS. All the things that I explained here, which is the GWLB balancer, it's actually what back it up the NSAS solution, but all the machines and the management and the SMS and everything, it's actually deployed by us. So we will handle it. So thank you, everyone. Thanks everyone for attending and keep this super long session. And I will return to the first page just to put the email addresses if you want to contact us for something. So I will be here. I will be listening some questions, and I will just keep for the next 5 minutes. I hope.
Thanks, Christian. Good job. Appreciate it.